Welcome to this video on the domain name system. In this video, we will explore how DNS help map these names to IP addresses and makes the internet easier to navigate, ensuring that whenever you type a website address, you are directed to the right server. By the end of this video, you will have a clear understanding of how DNS works and why it is so essential for browsing the web. The problem started when computers needed to connect to websites or other devices on the internet using IP addresses. To make things easier, we began using names instead of long strings of numbers like IP addresses. However, we needed a way to match these names with the correct IP addresses. Here's how this issue was solved. Initial problem: host files. At first, every computer had a host file that matched names to IP addresses. These fields had two columns, one for name, for example www.example.com, and one for the IP addresses. As more websites and devices appeared, these files became too large to store on every computer. It was also impossible to update all computers every time a new device or website was added or changed. The solution: centralized host file. Store the host file in a single location and allow all computers to access it. This creates a central system where all computers get the name to IP mapping. The second solution is DNS. The problem of first solution is it would cause heavy traffic to that central location, slowing down the whole internet. The second solution: instead of one huge host file, divide the file information into smaller parts and store it on multiple systems. Each computer can ask the closest system for the name to IP mapping. This system is called the domain name system. 6 steps to map host name to an IP address. User provides host name. The user passes the host name to the file transfer client. The file transfer client forwards the host name to the DNS client, which handles the DNS request. The DNS client sends a query to the DNS server using the known IP address of the DNS server. This query asks for the IP address of the desired file transfer server. The DNS server looks up the requested host name and sends back the IP address of the file transfer server to the DNS client. The DNS client then passes the IP address to the file transfer client. The file transfer uses the IP address received to establishes a connection and access the file transfer server. Two connections must be made in this case: mapping the name to an IP address and transferring files. The first connection is the DNS query to convert the host name into an IP address. The second connection uses the IP address to establish the communication and transfer files between client and server. This process allows smooth communication between users and servers and the internet. There are two ways to organize the mapping of names to addresses in a system: a float name space and hierarchical namespace. The first one, float namespace. In a float namespace, names are simple sequence of characters with no structure. Each name is directly assigned to an address. This system does not work well for large networks because it must be centrally controlled to avoid ambiguity and duplicate names. Managing it becomes difficult as the number of names grows. In a hierarchical namespace, each name is divided into multiple parts. These parts reflect different levels of the organization structure. The first part represents the type of the organization. The second part is the name of the organization. And the third part identify departments or subdivision within the organization. Unlike the float namespace, the hierarchical structure allows decentralization. Different parts of the name can be managed by different authorities. Additional suffixes or prefixes can be to the added to define the post or system within the organization, making the system flexible and scalable. To organize the millions of unique names and the internet, DNS uses hierarchical namespace. Here is a simplified breakdown. Inverted tree structure. DNS names are arranged in an inverted tree where the root is the top. The tree can have up to 128 levels numbered from 0 that representing row to 127. Each node in a tree has a label. A label can be maximum of 63 character long. The root label is an empty string, null. Each child node must have different label from its siblings to maintain uniqueness in domain names. A domain name is the sequence of labels separated by dots. As you move up the tree, domain names are read from the node up to root top level domain. A full domain always ends in a null label which is invisible to users. For example, the domain www.example.com, www.example and com are labels. These labels are read from the node www up to the root.com. The hierarchical system ensures that each domain name is unique and properly organized within the DNS structure. A zone refers to a portion of the DNS domain space that is managed by a specific DNS server or administrator. It is essentially the part of the DNS hierarchy for which a particular DNS server is responsible. A zone can consist of one domain or a portion of a domain, and it includes the records for all the names within that part of the domain. Zones are created by delegating authority over specific subdomains to different servers or administrators. A domain is a specific section of DNS hierarchy. It refers to any node or collection of nodes within the domain namespace and represent a name or group of names. Domains are represented by the sequence of labels separated by dots, forming a full qualified domain name. Fully qualified domain names. If the label is terminated by the null string, it is called fully qualified names. It contains the full name of the host, contains all labels from most specific to most general. DNS server can match an fully qualified name to an address. Example, challenger.atc.fhda.edu. Partially qualified domain names. If the label is not terminated by the null string, it is called partially qualified name. Partially qualified name starts from the node but does not reach the root. The resolver will supply the missing part called the suffix to create a partially qualified domain name. User at fhda.edu site wants to get the IP address of the challenger computer has to maintain the partial name. Example, challenger. The DNS client adds the suffix before parsing the address to the DNS server. Example, act.fhda.edu. In the internet, the domain namespace is divided into three different sections: generic domain, country domains, and the inverse domain. The first one is generic domains. It defines registered hosts according to their generic behavior. Each node in a tree defines a domain which is an index to the domain namespace database. Country domain uses two-character country abbreviations. For example, US for United States. Second label can be organizational or they can be more specific national designations. Example, ca.us. Inverse domain, it is used to map an address to a name. This happens when the server has received a request from the client. Type of query called an inverse or pointer query. To handle the pointer query, the inverse domain is added to the domain namespace with the first level node. Second level is also one single node named in address. Resolution. Mapping a name to an address or an address to a name is called name address resolution. DNS is designed as a client-server application. First, that needs to map an address to a name or a name to an address calls a DNS client called a resolver. After the resolver receives the mapping, it interprets the responses to see if it is a real resolution or an error and finally delivers the result to the process that requested it. The resolver gives a domain name to the server and asks for the corresponding address. If the domain name is from the generic domain, the resolver receives a domain name such as sol.atc.fhda.edu. If the domain name is from the country domain, the resolver receives a domain name such as ch.fhda.cu.ca.us. Mapping address to names, a client can send an IP address to a server to be mapped to domain name. The answer, the PTR query DNS uses the inverse domain. In the request, the IP address is reversed and two labels in address and ARPA are appended to create a domain acceptable by the inverse domain. The client can ask for the recursive answer from the name server. If the server is the authority for the domain name, it checks the database and responds. If the server is not authority, it sends the request to another server and waits for the response. If the parent is the authority, it responds. Otherwise, it sends the query to the another server. Iterative resolution. If a server is an authority for the name, it sends the answer. If not, it returns the IP address of the server that thinks it can resolve the query. The client is responsible for repeating the request to the second server. The client repeats the same procedure to the next server and so on. This process is called iterative because the client repeat the same query to multiple servers. Each time the server receives the query for a name that is not in the domain, it needs to be searched in database for a server IP addresses. So reduction in search time would increase the efficiency. DNS handle this with a mechanism called caching. DNS messages in the domain name system, communication between clients and servers occurs via DNS messages. These messages are exchanged in two types, queries and responses. Both are formatted similarly and carry the necessary information for name resolution. Types of DNS messages. DNS query messages. A client sends a query messages to a DNS server asking for the IP address corresponding to a domain name. The DNS server responds with a response message that either contains the requested information or an error if the domain is not found. Both the query and response messages have the same structure divided into several sections. The first one is header. This part controls how the message works. ID helps match the query and response. Clocks shows if the message is a query or response and whether the special features like recursion are used. Question section. This contains the question the client is asking. Domain name, what website the client wants information about. What kind of information the client is asking for. Answer section. This contains the answer to the question. Usually the IP address for the domain. Authority section. This part tells the client about the authority DNS servers for the domain if the current server does not know the answer directly. And finally, addition section sometimes includes extra information that may be useful, like the IP address of the authorities of the DNS server. Thank you for watching.